Hello friends, welcome back to our channel. So today we will see once again one more example of optimal binary search tree in algorithms concept. So we'll call it as OBST, optimal binary search tree. So in our previous session, we have discussed about this complete information about OBST. So what is a tree, what is a binary search tree, and how it differs from the optimal binary search tree. So if you are not seen that video, I'll post the link of that particular video in the description. First, go through that video so that you will be getting a clarity about the differentiation of tree binary search tree and optimal binary search tree. And in our previous class, we have seen one example that takes the frequencies of successful searches. And now today's session we'll see one more example which takes the frequencies of both successful and unsuccessful searches. Right? So let us take an example. Let us take some elements. So those are 10, 20, 30 and 40. So I'm taking only 4 elements, right? So in order to reduce the calculations, okay. So we need to construct the optimal binary search tree. That means we have to construct the binary search tree with a minimum number of comparisons for a successful search of each and every element of that particular tree. So obviously here the question is which we have to select it as a root. Then we can get the optimal binary search tree. So with this we can have a multiple binary search trees. We can construct a multiple binary search trees. Among that we have to decide which will be the optimal binary search tree. That means minimum number of comparisons. With the help of minimum number of comparisons, how efficiently we can get the search, right? Now let us take some P of I. Let us indicate P as a successful searches, which is from 1 to 4. Let us take the frequencies as 3, 3, 1, 1. That means the frequency of first element, to search for the first element is 3, and the second element is 3, the fourth element is 1, and fifth element is 1. And similarly, let us consider a Q as unsuccessful. So obviously, that will be from 0 to 4, because so if we are having 4 elements, in our tree, so we have to compare all these 4 elements, and in the fifth element we will be getting the fifth comparison, we will be getting the unsuccessful, right? So fifth element we will be getting the fifth comparison, we will be getting the unsuccessful. So the unsuccessful nodes will be 5 and successful nodes will be the number of elements. If n elements are there, the successful frequencies will be n and unsuccessful frequencies will be n plus 1. So let it be some 2, 3, 1, 1 and 1. So that's why we have given it as 0 to 4, P as 1 to 4. Right? Now we have to start executing. So let us write the formula first. So whichever the formula we have done, the same thing we have to apply here. So what's the formula we have done? C of I comma j is equal to minimum of I less than k less than j, and from here we have to apply C of I comma k minus 1 plus C of k comma j plus W of I comma j. So this is a formula where we have to find the cost of the element, to search the element, cost. And the next one, similarly R of I comma j is equal to k. That means for which k value we got the minimum cost. So we need to consider the element as a root. So this is particularly for the root element, to select the root element. So for which k value this particular expression we are getting a minimum value, that will be the k value and that will be considered as a root. So that will be considered as a root of ij. Now W of I comma j is nothing but W of I comma j minus 1 plus P of P of j plus Q of j. So this is the formula. This is a formula we have to calculate the W of ij. So this is a somewhat different, which we have not calculated in our first example. That means when we have taken only the successful frequencies. But here in this example, we are taking the two different frequencies, successful and also unsuccessful. So based upon these two, we have to find out the optimal binary search tree. Now, the initial conditions. Initial conditions. So what is the initial conditions? Whenever it is I comma I, that means whenever j becomes I, whenever the j becomes I, then that will be a q of I. So it will be q of I. And similarly, cost will be 0 and obviously root will be 0. See, simple. This is nothing but when the tree structure doesn't have any elements. If tree structure doesn't have any elements, obviously in the first thing only we will be getting the unsuccessful. Yes or no? So for example, we are searching for element 10 and initially there is no tree. There is no tree. Then obviously what happens? For the first frequency itself, we will be getting the unsuccessful. So obviously, so Q of j will be the weight. And what about the C of ij, cost to search? So if there is no element, there will be no cost. If there is no tree, there will be no root. So that's why these two becomes 0 and this becomes the unsuccessful. This becomes the unsuccessful. So now we have to draw the table for searching of the root element. So which one should be a root? Right? So the root should be for elements 0. So this is this thing. And what is the root for element 1? If there is only one element, then what will be the root? Itself will be the root. Right? And if there are two elements, for example, we are having here 4 elements. That means 4 nodes. 4 nodes. So we can consider 0 nodes. What is the root? So obviously 0. Okay. Then if there is only one node, what is the root? If there are 2 nodes, what is the root? So we have to find out the minimum root, right? So what is 3? If the tree is having some 3 nodes, what is the root? And if it is having some 4 nodes, what is the root? We have to calculate that root value. Okay. And this happens when j minus I is equal to 0. That means j and I is equal to 0. Both are the same, right? If this becomes j minus I is equal to 1. And this becomes j minus I is equal to 2. This becomes j minus I is equal to 3. This becomes j minus I is equal to 4. So we need to calculate the cost, weight and root for all these cases. So whenever j minus I is equal to 0, whenever j minus I is equal to 1, whenever j minus I is equal to 2, whenever j minus I is equal to 3, whenever j minus I is equal to 4. That implies here 0 means 0 nodes in the tree. If it is 1 node. If it is 2, there are 2 nodes in a tree. Among that we have to select the optimal. That means a minimum cost. And here j minus I is equal to 3 means if the tree is having 3 elements, what is the root we need to calculate? So in order to get the optimal binary search tree. And j minus I is equal to 4 means if the tree is having 4 elements, which one should be considered, right? Now, see. Now, let us draw the tabular form. So I'll draw the tabular form here. So I'll take 0, 1, 2, 3 and 4. 0, 1, 2, 3 and 4. So we need to fill the table and find out the root and apply the backward process so that we will be getting the complete tree structure, right? So let us check out. So for every case, we are supposed to find the weight, cost, and also root. Weight, cost, and root by using these formulas. Now, so this is a I value and this is a j value. I value and j value. Now, initial conditions, and we have seen, and every time, see, by using this formula, I'll calculate each and everything and here, and we'll update the table here. Now, initial conditions, whenever I minus j, I is equal to I, that means first one, j minus I is equal to 0. J minus I is equal to 0 means, so there are no nodes in a tree. If there are no nodes in a tree, obviously the cost will be 0, the root will be 0. But the weight, that means the frequency, will be 2 or 3 or 1 or 1 or 1. Okay, let us check. So this implies I is equal to, sorry, j is equal to I. J is equal to I. So we'll get W11 is equal to, okay, W of 1, 1. W of 1 comma 1. I is equal to j. Okay. So what is the value? Q of I. Q of I. So that means Q of 1. Q of 1. So what is the Q of 1? See, 0 and 1. Q of 1 is 3. So 3 will be the weight. What about the cost here? I'll write the cost here. So C of 1 comma 1 is equal to, so if both are equal, then it will be 0. So 0 and root of 1 comma 1. So what is the root of 1 comma 1? That's also will be 0. Right? So update here. 1 1. Okay. So if it is 1 1, it will be 3 and so on, right? So 1 1. So W of 1 1 is equal to 3. C of 1 1 is equal to 0. R of 1 1 is equal to 0. Okay. Now, let us also consider W of 0 comma 0. So then it will be Q of 0. Okay. Then Q of 0 means it will be 2. C of 0 comma 0, which is 0. R of 0 comma 0, which is 0. So yeah, this is 1 0, no? So we need to update here, not here. So this is the place. W of 1 1 is equal to 3. Yes. C of 1 1 is equal to 0. R of 1 1 is equal to 0. And here W of 0 0 is equal to 2. C of 0 0 is equal to 0. R of 0 0 is equal to 0. Right? Now 2 comma 2, then also it will be 0, right? So Q of 2. So what's the value of 2? Q of 2 is this is 0 1 2. It's a 1. And C of 2 comma 2, which is 0, and R of 0 comma 0, it is again 0. So 2 2. So W of 2 2 is equal to 1. C of 2 2 is equal to 0. R of 2 2 is equal to 0. Okay, we'll extend this one. Right. Now, again W of 3 comma 3. So again it will be Q of 3. So Q of 3, which is again 1. C of 3 comma 3 is equal to 0. R of, yeah, here it is 2 comma 2. 3 comma 3 is equal to 0. So this position. So W of 3 3 is equal to 1. C of 3 3 is equal to 0. And R of 3 3 is equal to 0. Okay. So same thing. Now W of 4 comma 4. So we need to consider each and every condition, right? Every case, each and every case we have to calculate. So W of 4 comma 4 is Q of 4. So which is again it is 1. And C of 4 comma 4, it will be 0. And R of 4 comma 4, if there are no elements, then automatically root will be also 0. So W of 4 4 is equal to 1. C of 4 4 is equal to 0. R of 4 4 is equal to 0. Okay. So same thing, we have calculated all the roots. Okay, all the roots, a k value or weightage and a cost for 0 elements of a tree. If the tree is having 0 elements. Now if the tree is having only one element, if tree is having only one element, that is j greater than I. Now what are the weight, cost and root? If tree is having only one element, okay, consider tree is having only one element. So obviously W of 0 comma 1, which is 1 minus 0, it is 1, right? Now what we have to calculate, W0 of 1 is equal to W of I value 0 comma, next what's the formula here, j minus 1, y minus 1 0 plus P of j is 1 plus Q of j 1. So which is nothing but W of 0 0. W of 0 0 is 2. So 2 plus P of 1. P of 1 3. Q of 1. Q of 1 is this one. So this starts with 0, right? So this is 0, 1, 2, 3, 4. So that's why I have written a key here 0 to 4. And here 1 to 4, 1, 2, 3, 4. So Q of 1 means this one, 3. So which is nothing but 8. Okay. Now calculate the cost from 0, 1, which is a minimum of 0 less than k less than or equal to 1 C of, so here k holds only one value. That means the k is in between greater than 0 and less than or equal to 1. Greater than 0 and less than or equal to 1. So that means it will take only one value. So now C of, what's the formula here? I means 0 comma k minus 1. Here k is 1. 1 minus 1 0 plus C of k. K means 1 comma j. J means 1 plus W of 0 comma 1. So W of 0 comma 1 already we have calculated here based upon the successful and unsuccessful searches. So what is the value here? So then here we are taking only one value, so that will be the minimum value. So if there are multiple k values, so that way there will be getting a multiple value. So from that we have to select the minimum value. So but here we are having only one value. So C of 0 0, C of 0 0, it is 0 plus C of 1 1, 1 1 again it is 0 plus W of 0 1. W of 0 1 here we have calculated, so 8. So which is nothing but 8. And obviously the root of 0 comma 1 is equal to k. See, k. So here what is the k value? 1. So 1. So what's the values? 8, 8 and 1. So whenever j minus 1, I is equal to 1, W of 0 1, C of 0 1 and R of 0 1. So we need to fill this one. So 0 1, 0 1 means this one. So W of 0 1 is 8. C of 0 1 is again 8. R of 0 1 is 1. Okay. Now what we have to do? Again we need to calculate a few more things. So which is W of 1 2. So in this case also the j minus I value is 1, right? So is equal to W of 1 comma 1 plus P of j, that means 2, plus Q of j, which is 2. So W of 1, 1. 1 W is 3 plus P of 2. P of 2 is 3. Q of 2, 0, 1, 2, it is 1. So which is 7. And C of 1 comma 2, which is nothing but a minimum of 1 less than k less than or equal to 2. And C of I k minus 1, that means 1 plus C of j, k is 2. Here k value is only 2. So 2 comma j, that means 2 plus W of ij, 1 comma 2. So here the k value will be only one value, right? So because k value will be greater than 1 and less than or equal to 2. So k is equal to 2. C of 1, 1. C of 1, 1. It is 0. Now C of 2, 2. C of 2, 2 again it is 0. Plus W of 1, 2, which is 7. So that is 7. So a root of 1 comma 2. So only one value k is there. So that will be a 2. So what we have to do? So we have to fill the three things here. So 1, 2. So this one. So W of 1, 2 is equal to 7. And C of 1, 2 is equal to 7. And R of 1, 2 is equal to 2. Right? Now, one more thing, that is 2, 3. This place. This will also be 3 minus 2, 1. Right? So C of 2 comma 3. So we need to calculate C of 2 comma 3. So C of 2 comma W of, first we need to find out the weight, because we have to add this weight in the C cost, right? So W of I comma j minus 1, 2 comma 2 plus P of j, that is 3, plus Q of j, which is again 3. So W of 2, 2 it's 1 plus P of 3. So 1, 2, 3, it's 1. Q of 3, 0, 1, 2, 3, it's again 1, which is 3. And cost of 2 comma 3 is equal to a minimum of 2 less than k less than or equal to 3. And C of, so here the k value will be only one element, that is a 3. One value, it's a 3. So C of I, that means 2, k minus 1, again it is 2, plus C of k, which is 3 comma j, j is again 3, plus W of ij, that means 2 comma 3. So what happens here? C of 2, 2. C of 2, 2 is 0, plus C of 3, 3. It's again 0. So yeah. So this is 1 comma 2. 1 comma 2. Okay. So W of 2, 3, it's a 3. Okay. And here R of 2 comma 3 will be k. K is here only one value, that is a 3. So 3, 3, 3. So 2 comma 3, this place. 2 comma 3. W of 2, 3 is 3. C of 2, 3 is 3. R of 2, 3, it is, again it is 3. Again it is 3. Now, one more case, that is 3, 4. This also, the difference is 1, right? So W of 3 comma 4. So which is W of I j minus 1 plus P of j plus Q of j. So which is W of 3, 3. It's a 1 plus P of 4. It's 1 plus Q of 4. It's 1, which is 3. And cost of 3 comma 4, it will be a minimum of 3 less than k less than or equal to 4. So the k value holds only 4, right? Now C of I comma k minus 1, it is 3 plus C of k comma j, right? Plus W of ij. So 3, 4. So which is nothing but a 0 plus 0, 3, 3, 4, 4. C of 3, 3, C 4, 4. Plus W of 3, 4 is 3. So which is nothing but 3. And R of 3 comma 4, which is nothing but a 4. Okay, k value is 4. So fill here, W of 3, 4 is 3, W of, C of, after weight, cost. C of 3, 4 is again 3, R of 3, 4 is 4. Okay, now see, this is completed. This diagonal is completed, right? That means if the tree is having only one element, right? Now, let us consider the second one. If tree is having two elements, that is j minus I is equal to 2. So j is greater than I. We need to find out W of 0, 2, W of 1, 3, and W of 3, 4, 2, 4. See, 0, 2, 1, 3, and 2, 4. So this diagonal. Right? Now W of 0, 2, which is nothing but W of I, j minus 1. So 0, 1 plus P of j 2 plus Q of j. Again it is 2. So W of 0, 1. What is that 0, 1? W of 0, 1. It's a 8. 8 plus P of 2, P of j. P of 2 means 1, 2. This is 3. Q of 2, 0, 1, 2. It is 1. So which is nothing but 12. And the cost of 0, 2, so which will be minimum of 0 less than k less than or equal to 2. So here you will be getting k value as 1, 2. So two values we are getting. So we need to consider only one thing which is having the lowest value. So minimum value, right? So C of whenever k is equal to 1, then it will be 0, 0 plus C of 1, 2. Similarly, C of wherever k is equal to 2, 0, 1 plus C of 2, 2. So we need to consider minimum from these two, and we have to add it to W of 0, 2. So what's the values here? The minimum of, let us take the value C of 0, 0. C of 0, 0 is 0 plus C of 1, 2. 1 and 2. C of 1, 2 is 7. And here C of 0, 1. 0 and 1. C of 0, 1 is 8 plus C of 2, 2. C of 2, 2 is 0. Plus W of 0, 2. 0, 2 is 12. So among these, so what is the minimum value? 7. 7 plus 12, it will be 19. 7 plus 12, it will be 19. Now root of 0, 2 will be k. So in which k value we have got the minimum value? Obviously in the first case. In the first case, what is the k value? 1. So R of 0, 2 will be 1. R of 0, 2 will be 1. So we need to update the same thing here. So 0, 2. So W of 0, 2 is equal to 12. C of 0, 2 is equal to 19. And R of 0, 2 is equal to 1. So here you can see we are having a 2 k values. Among those 2 k values, for which k value we are getting the minimum value, that should be considered as a k. So in these two, the first case we are getting the minimum value as 7. So for the first case, the k value will be 1. So that will be stored in R02. Now one happened. Now we have to calculate W of 1, 3. Now we have to calculate W of 1, 3. So W of 1, 3 is equal to W of I means 1, j minus 1, 2 plus P of 3, that means j, plus Q of j, it's again 3. So what is the value of W1, 2? 1 and 2, it is a 7 plus P of 3, 1, 2, 3, it's a 1 plus Q of 3, 0, 1, 2, 3, it's again 1. So which is nothing but a 9, value of 9. So cost of 1, 3, C of 1, 3 is a minimum of 1 less than k less than or equal to 3, which holds the k values as 2, 3. So we need to find out the cost. C of I, 1 and k minus 1. Let us consider k as 2. 2 minus 1, 1 plus cost of k means 2 and j, 3. And the second case, C of I, 1, k minus 1. Now k, let us take k as 3. 3 minus 1, 2 plus c of 3 comma 3 plus a weight of 1 comma 3. Now you can consider here minimum of C11. C11 is 0 plus C23. C23 is 3 and C12 is 7 plus C33. C33 is 0 plus W of 13, which is 9. So that implies among these two cases 3 is minimum. So 3 plus 9 is 12. Now R of 1 comma 3. So we got a 12. Okay, and among these two cases we are taking the first case as a existence, because the first case we are getting the minimum value. In the first case, what is the k value? 2. So now R13 will be 2. So update here. So what is that one? 13, right? This one. So W13 is equal to 9. C13 is equal to C13 is equal to 12. R13 is equal to 2. R13 is equal to 2. So 3 is again 0, right? So we should be very careful about these values, right? Now there is one more case, which is 2, 4. We need to calculate the weight, cost and root for 2, 4. 2, 4. Okay, the nodes of 2 and 4. So W of 2 comma 4. So that means we are calculating for every combination, right? So C of W of 2 comma 4. So 2 comma 4, you can see W of 2 comma 3 j minus 1 plus P of j 4 and Q of j 4. So W of 2 3. 2 and 3. It's a 3 plus P of 4, which is 1, and Q of 4, which is again 1, which is nothing but a 5. And C of 2 comma 4 is equal to a minimum of 2 less than k less than or equal to 4. So which k holds the values 3 comma 4. And C of I, it's 2, k minus 1. First case k is 3, 3 minus 1, 2 plus C of k, 3 comma j 4. And the second case again, now k, consider k as a 4, 4 minus 1 it is 3 plus C of k, it's a 4 comma j is 4 plus a weight of 2 comma 4. So now consider the minimum among these two. C22, C22 is 0 plus 3 4, 3 and 4 it's a 3, 2 3, 2 3 it is 3, see 2 3 it is 3, yeah, plus 4 4 it is 0. So you can consider any value, k can be either 3 or 4, right, plus 5, so which is nothing but 8. So R of 2 comma 4 will be either 3 or 4, anything you can consider. I will consider it as 3, okay, because both are same. Now update here, W of 2 4 is equal to, W of 2 4 is equal to 5, and C of 2 4 is equal to 8, and R of 2 4 is equal to 3 or 4, whatever it may be. You can consider anything, right? So here R is 4, 4 is equal to 0. So now we have calculated the root. We have find out the root if the tree consists of 2 elements. That means the difference between I and j should be 1. Sorry, 2. Now we have to consider this one. J minus I is equal to 3. Now that means if the tree is having 3 nodes, okay, if tree is having 3 nodes, which one should be considered as a root? So for this we have to calculate the things like W of 0 3 and W of 1 4. So 0 3 and 1 4, right? Now a W of 0 comma 3 is equal to W of I j minus 1 2 plus P of j 3 plus Q of j 3. So I am applying only these formulas. So is equal to, I'll write here itself, okay. W of 0 2, W of 0 2, it's a 12, plus P of 3 1 2 3, it's 1, and Q of 3 0 1 2 3, it's 1. So which is nothing but 14. W of 0 3 is 14. And similarly C of 0 comma 3, and here we are getting minimum of 0 less than k less than or equal to 3, where k will be holding the values of 1 2 and 3. So we are getting 3 values. Now first case, consider k as 1, so C of I k minus 1 0 plus C of k 1 and j 3. Second case, C of I g 0 k minus 1 2 minus 1 1 plus C of k 2 and j 3. And third case, 0 C of I 0 k is 3 k minus 1 it is 2 plus C of k 3 and j 3. And then add a W of 0 comma 3. Now you can consider here a minimum among these three values. C0 0 it will be 0 plus C1 3 1 3 C1 3 it is 12 and C0 1 0 1 it is 8 plus C2 3 2 3 it is 3 and C of 0 2 0 2 it is 19 plus C of 3 3 it will be 0 plus W of 0 3 which is 14. So among these, which one is the lowest? The second one. 12, 11, 19. So 11. 11 plus 14. So this is the minimum value. 8 plus 3. So 11 plus 14. It is a 25. 25. Now what is the root of 0, 3? When the k value becomes the minimum. So second case k value is 2. So R of 0, 3 is 2. Now you can see 14, 25 and 2. Update here. So W of 0, 3 is equal to 14, C of 0, 3 is equal to 25 and R of 0, 3 is equal to 2. Okay, and we have to check with one more case, that is 1, 4. 1, 4, calculate the same, apply the same formula for this to calculate the weight, cost and root. So W of 1 comma 4, so which is equal to W of I 1 j minus 1 3 plus P of j 4 and Q of j 4. So W of 1 3, W of 1 3 it is 9 plus P of 4 it is 1 plus Q of 4 it is again 1. So which is 11. Which is 11. Now we need to find out the cost. So cost of 1 comma 4, it will be a minimum of 1 less than k less than or equal to 4. So k value will be 2 comma 3 comma 4. So first case C of I 1 k minus 1, here k first case 2 2 minus 1 1 plus C of k which is 2 j it's a 4. In the second case k will be 3, so 1 comma 2 k minus 1 2 plus C of k 3 and j 4. In the third case k value will be 4, C of I 1 k minus 1 it is a 3 plus C of k 4 and j 4. So which should be added with a weight of 1 comma 4. So here we have to find out the minimum among all these three. C of 1 1 it will be 0 plus 2 4 2 and 4. C of 2 4 it is 8 and C of 1 2 C of 1 2 it is 7 plus C of 3 4 3 4 it is 3 and again C of 1 3 1 3 it is 12 plus 4 4 it is 0. So among these three the first case is having the minimum value, so W of 1 4 is 11, so which will become 19. So root of 1 comma 4 will be obviously the first case, that means 2. Update this in the table, right? So here we have to update W of 1 4 is equal to 11, C of 1 4 is equal to 19 and R of 1 4 is equal R of 1, 4 is equal to 2. So first case, it's a 2. Okay. So this we have done. Now, in the last case, we need to find out the root when the difference is 4. That means element is having some 4 elements. Okay, the tree is having 4 elements. So our element is also 4 elements, right? The number of nodes we have taken is 4. So this will be the last case. So it will be 0, 4, this part. So we need to calculate the same formula. We have to apply the same formula and calculate the weight, cost and root. So weight of 0, 4 is equal to W of I 0, J minus 1 3 plus P of J 4 plus Q of J 4. So W of 0 3, W of 0 3, which is a 14, and plus P of 4, it is 1, Q of 4, it is 1, so which is 16. And similarly C of 0, 4, which is a minimum value of 0 less than k less than or equal to 4. K holds the values 1, 2, 3, 4. So 4 values. So when in the first case k value will be 1, second case k value will be 2, third case k value will be 3, fourth case k value will be 4. So C of I means 0, k is 1, 1 minus 1, 0, plus C of k, 1, J 4. This is the first case. Second case, C of I 0. Now I value, k value is 2, 2 minus 1, 1, plus C of 2, 4. Third case, k value will be 3. So C of 0, 2, 3 minus 1, plus C of 3, 4, k, j. And the fourth case, k value will be 4, C of 0, k minus 1, 3, plus C of k value is 4, j, 4. J value is 4. So plus weight of 1, 0, 4. So we need to calculate the minimum among these 4 cases. So what is the first one? So 0 plus C14. C14, it is a 19. C01, C01 is 8 plus C24, 24, it's again 8. And C02, 02 is 19. C34, it's a 3. C03, 03 is 25. And C of 44, it is 0. So among these, the second case we are getting the minimum 16, right? So plus it is 16. So which will be 16 plus 16, 32. So R of 0, 4, in which k value we got a minimum value? Second case k value is 2. So 16, 32 and 2. Update here. So W of 04 is 16. C of 04 is 32. R of 04 is 2. Here 2. Right? So here we have completed the root nodes, finding of root nodes for each and every case. So the same thing we have applied in the first case also. That means first example in our previous session. But there we have considered only the successful frequencies. But here we are also considering the unsuccessful frequencies. So the calculation of this particular W weight will be different. Okay, that's the only difference. The formula of C is same and also root is same. Now we have completed this one and we know the root. What is the root? Okay, if the tree is having 2 elements, 3 elements, 4 elements, 1 element and 0 element. Now we need to construct the tree. Yes. Let us consider this one. Let us consider and let us draw the tree. So only thing is we have to consider it from R of 0, 4. Okay. So R of I, j. Sorry. This is j, which is a k value. So the left tree will be R of I, k minus 1. And right side element will be R of k, j. Okay, again it will be the k values. Whatever the result we are getting, that will be the k values. Consider this one. So R is having some 4 elements. That means the tree is having some 4 elements. We need to start from R of 0, comma 4. What is the R of 0, comma 4? 0, comma 4. It is 2. 2. So here 2 means the second element. So elements, these are the elements, right? So 1, 2, 3 and 4. Second element. Now the left is R of I comma k minus 1. 0 comma k minus 1. It's a 1. R of 0, 1. What is the R of 0, 1? R of 0, 1 is 1. So here it is 1. And now here it will be R of, so this is a k value, right? K comma j, 2 comma 4. So what's the R of 2 comma 4? R of 2 comma 4, it is a 3. 3. And this is the k value, and here this is the k value. Again, the left of this one will be R of 0 comma k minus 1, which is 0. What is the R of 0, 0? It's a 0. So there is no element. If there is 0, that means it is a no element. Okay. So here on the left hand side, R of, what's the k value? 1, j value 1. R of 1, 1, again it is 0. So we need to stop here. This is no element. Now consider this one. So R of 2 comma k minus 1, 2. 2 comma 2. It is again 0. We need to consider. Next, R of 3 comma 4. R of 3 comma 4. It is a 4. Right? And here we need to consider R of 3 comma 4 minus 1, 3. It is 0. Should not consider. This one, R of k. K means 4. So here it is a k. Okay. So 4 comma 4. Which is 0. So that's no. Now this is the optimal binary search tree. Now replace these k values with the corresponding elements. So here 2 means second element. So 20. Okay. On the left hand side, 1 first element. It is 10. On the right hand side, third element, that is 30. And see, again on the left hand side, it is 40. You can see the third element, fourth element. So this is the optimal binary search tree for the given example. You can observe here the root element will be one thing, and all the left subtree will be the less than root elements, and the right subtree will be the greater than root element. You can consider anything. 20. So left subtree 10, which is less than 20. Right subtree it is 30, which is greater than 20. And again 30 is having 40 on the right hand side. So 40 will be the greater than 30. So this is the optimal binary search tree we can construct from the given elements for both the successful searches and unsuccessful searches. Okay, so just remember this formula to construct the tree. R of ij, which is left hand side it will be I comma k minus 1, right hand side it will be R comma k comma j. So here the k means nothing but corresponding element numbers. Okay, root elements, right? So first we have to consider, or first we have to calculate what is the weight, cost and root. Based upon the weight we are calculating the cost, and based upon the cost we are selecting the root element. So for which for when the k value we are taking, we are getting the minimum cost, we are considering that element as a root element. So from this table we are constructing this particular tree. So this is the optimal binary search tree, so with a less number of comparisons. Right? So once again, so we are starting from the root element ij, that means 0, 4. For this 0, 4 we need to calculate the 0, 1 and 2, 4. For 0, 1 we have to calculate 0, 0, 1, 1. So first we are calculating the 0, 0, 0, 1. See all these things. First 0, 0, 0, 1, 0, 2, 0, 3, 0, 4. So like that we are calculating from the leaf nodes to the root node. So this is a bottom up. And this process we calling as a tabulation process. Tabulation process. Right? So hope you understood this one. And if you feel any difficulty at any position or any place, while calculating. So feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. And if you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.